good afternoon, everyone. And what Jennifer and I are going to do is have a fireside chat. Now, unfortunately, we're not sitting at a fireside. We don't have a nice single malt at our hands to get us going. But what we want to talk about and then share with you is the future of digitalisation and the built environment. So as we enter the next decade of CSIC, what does the future hold for digitalisation and the built environment? And as we're looking forward, it's always sensible to look back and to try and learn how things have developed over a certain period of time. And so Jennifer, let's get started. There are two key things here: digitalisation and the built environment. And I suppose we could drill down a little bit just to try and understand what we mean by the built environment. So what does it mean? What does the built environment mean to you? And how has it changed? How has it evolved over the last 10 years? And how do you think it will evolve over the next 10 years?
Thanks, Mark. Well, I guess, the built environment can mean many things to many people. And to me, built environment means that assembly of things that humans have constructed. So be it roads and energy and water infrastructure, or houses and offices and factories, the places we go to work, or the theatres and cinemas that we spend our free time in if we're lucky. That to me is all part of what we might call the built environment, things that we have created. And I think it's been, my time in CSIC has been really interesting, because I've seen, even over just the last 10 years, our view of the built environment and how we manage it has changed as an industry. So when I first arrived at CSIC, I think that kind of the discourse within both academia and the industry was very much around the built environment as a collection of individual assets. So, houses or bridges or roads or tunnels. And we were very much thinking about things like structural health monitoring, for example, in the context of that individual asset's health and its capacity and its capability. And we thought about energy use at the level of individual assets. But over the last 10 years, I've seen that really change, I think, and move from this sort of idea of a collection of individual assets to much more of a system or system of systems view. And I think, we've been doing some of that at CSIC. There's been a lot done at the Centre for Systems Engineering and Innovation at Imperial, and really across academia, but also industry, where people have started to recognise that we have to take this system of systems more complex view. Because if you think about it, everything in our built environment is interdependent. So our houses don't function well unless the power and the water supply function. Our energy systems don't work well unless we have the cooling systems for them, which is often provided by water. And likewise, the water systems need the energy in order to purify the water, pump the sewage and so on. So they are very much a system of systems. The challenge for us, I think, is that they weren't designed that way. So they were designed as this sort of, as a set of individual systems and a set of individual assets. And they've evolved gradually over the last 200 years or so, since we've been building pretty serious infrastructure. And a lot of that infrastructure actually that was built by our forefathers 150, 200 years ago is still in use. So there's an increasing recognition that we need to think about these things as interrelated and interlocking systems, and that the existing assets that we have around us are as important as the new things that we build. Apparently we add about 0.5% by capital value to the total amount of physical assets we have around us each year. So even huge projects like HS2, which is, in the tens of billions of pounds, is only adding a small fraction to the total value of those physical assets. And we can't go just replacing everything. We don't have the resources to do that. We don't have the space to do that. So we have to make the most of everything that we have around us. And that is increasingly what I've seen the industry take on board. And in CSIC, a lot of that has been reflected by the work that Ajit Parlikad has led on value-based whole life decision-making. So sort of standing back and looking at, let's say, your road network or your rail network, and understanding not just the value of the individual bridge or tunnel, but actually the service that it provides within your network. So if your network rail, your industry's, your business's purpose is not to maintain bridges, it's to enable people and goods to move around using railways. You have to have bridges because physics says that that's the only way to get people across gaps. But they're there to help serve the purpose. And if you have, as Network Rail does, tens of thousands of bridges, and they're all in different ages and different states of health, you have to decide where you're going to put your limited asset management budget based on not just the condition of the assets, but also how critical they are to delivering your service. So that, I think, is a conversation that when I first joined CSIC, people didn't really have that whole life view and that system of systems view. But much more, both in academia and in industry, I'm seeing that start to be the sort of the dominant conversation. And I think, as well as understanding our built environment as a system of systems, it's also starting to be seen much more as much more than that. It's actually a system of systems that deliver services, and that those services are intended to help support human flourishing. You know, we live in cities because they're great places to be. We depend so much on our infrastructure services and our social infrastructure, and most of the time we just assume it's going to be there, and we only notice it when it goes wrong. But the quality of life that brings to us, if we think back 200 years to before we had functioning sewage systems and water supply systems, London was gripped by a cholera epidemic. People were dying all over the place. And the infrastructure that was built made a massive change to public health and helped the quality of life. So these systems are systems to enable human flourishing. And then the last thing that I've seen change, probably only in the last 2 years, starting with the climate justice movement and the Fridays school strikes for climate and that kind of thing, and then sort of enhanced in a way by the pandemic and everyone's appreciation of the need to enjoy outdoor space, is this move from seeing the built environment as something separate to nature and the natural systems as being something that's inherently part of nature and the natural systems. So increasingly, when we're talking about new infrastructure, for example, the environmental impact assessment isn't just, oh, well, you know, how much can we avoid damage, but actually how can we help improve biodiversity? How can we help improve flood management? How can we benefit the environment and that system of systems whilst we're doing the things that we need to do with the built environment? So this sort of understanding of our built environment and ourselves as part of a planetary system of systems, if you like, is something that I think has had a rapid takeoff in the last 2 years. Not to say people weren't talking about it and thinking about it, but I think it wasn't mainstream in the industry culture or the popular culture. But now it feels to me much more like having those kinds of conversations. You're not seen as a bit kooky and you know, someone who goes and hugs trees. You're seen as someone who's in the mainstream of the discourse. And the other thing that I've seen change hugely is actually this acceptance that digitalization has a role in helping us to achieve a resilient built environment. So a built environment that can respond to not just climate shocks, although obviously we need to respond to those, but also changes in demographics, changes in need, the need to be able to support an aging population. And the fact that digitalization and data has a real role to play in helping us understand how we use our built environment, what condition it's in, how we ought to be designing resource efficiently so that we use fewer resources and so that the assets that we're building over their lives use fewer resources. And this appreciation of data as an asset in its own right, I think, is something that perhaps our sector was a little slow to come to, but is now really grasping. We're struggling to work out how we do it, I think, still. You know, how do we value the data as an asset? How important do we see it as being? And therefore, how much investment can we afford? And how far should we go down that digitalization journey? I think is still something that our sector is grappling with, but it's very much on the agenda. So yeah, I think in summary, we've moved from collections of assets to systems of systems, and seeing our built world as part of that wider planetary system, you know, with the natural, I don't like the word ecosystem services because it sounds a bit exploitative, but the natural environment being an inherent part of what we need to think about. And then digitalization as this new tool, it's not new to everyone, it's new to us, that can help us do all these things more effectively. But Mark, I'm not the expert in digitalization, so I'm going to flip it over to you now and ask you, what do you think digitalization means? What is digitalization? We bandy these words around so much: digitalization, digital twins, data information. But what do you think digitalisation is, and how has that concept evolved over the last 10 years? And perhaps where do you think it's going in the next 10 years?
So I was really glad to hear, Jennifer, that you actually expanded the time scale that we were discussing from 10 years to 200 years. And I think to answer the question about digitalisation, I'm going to have to use that similar time scale of a couple of centuries. So, I mean, digitalisation it's a buzzword. It's a buzz phrase that enters into our common language. It's a very succinct and direct way to describe some sort of phenomenon that we're experiencing, and that's typical in business. But to get a sense of digitalisation and everything around it and the implications that it has, I want to take us back to 18th century Birmingham and to a meeting of the Lunar Society of Birmingham. Now, Birmingham, of course, at that time was the epicentre of the Industrial Revolution. And the Lunar Society was one of these societies that sprung up at the time of the Enlightenment in similar fashion to the Linnean Society and to the Royal Societies of London and Edinburgh. And the sort of people that met at the Lunar Society in Birmingham were people like Priestley, who discovered oxygen, Wedgwood, the great potter, Watt, everyone knows, of course, the great Glaswegian that developed the separate condenser. Erasmus Darwin, one of the great Enlightenment thinkers of that period. And these were all philosophers, natural philosophers, inventors, and they met to discuss whatever was on their minds. The thing is, and that was different from the Lunar Society and the Royal Societies of London and Edinburgh, is that it was based in Birmingham, and it had this industrial backdrop that gave an additional dimension and a really fertile ground for the adoption and the pool, the sort of forward-thinking ideas that the lunar men had been working upon. And if you think of Wedgwood, I mean, Wedgwood just gobbled up all of the scientific advances that came out of that society to produce better pottery, the pottery that the market was demanding, and to do it more economically and to operate his potteries in far more commercially successful ways. And of course, Watt's inventions of separate condensers and so forth, or steam engines, had direct relevance to the industrial need for power. And I mean, the reason that I'm going back this far is because, in essence, what this gave rise to was another buzzword, which has been around for a very long time, which was automation. And automation was the driver of the Industrial Revolution, moving from cottage style to factory scale production, certainly in the case of mills and potteries. But if we think a bit more broadly about automation, not only did it drive the development of industrial scale production, it also transformed every aspect of social activity. I mean, the printing press centuries earlier displaced the need of, writers and then mechanical calculating machines, automating and scaling the ability of, bookkeeping, inventory management, and so forth. So if we look way past this decade, one of the most enduring facets that underpins digitalization is automation. And automation has impacted and is impacting every aspect of human endeavor, and it continues to do so now. And, the lunar men provided new chemical and new mechanical based technologies for the industries in the day. One of the forerunners of digitalization or digital technologies was, of course, electrical technology. And the advent of electrical technologies, if you think about it, the employment of street lighters was more or less snuffed out. if you excuse the pun. Now, I've just been told my internet is unstable. Am I okay? Can you hear me?
Mostly, you're
Jennifer,
dropping in and
am I
out a
good,
little bit,
or?
but it's not too bad.
Okay. You know, the advent of electric-based lighting systems displaced gas lighting systems, and overnight, a whole industry disappeared, and another whole industry appeared and developed. Think of telegraphy and then subsequently radio, how it transformed communication. And so mechanical computing, type of mechanical computing that Babbage and Kelvin developed and employed, gave way to analog electrical computing. So computing machines that transformed business, automating accounting, invoicing, payroll, office systems, communication systems. If you think of companies like International Business Machines, IBM, that's exactly what they did. They built machines to help businesses, and they moved from mechanical machines, cash registers, to electrical devices, electrical typewriters, analog computers, to automate business, and eventually to digital technology. And so digital technology is basically embodying and enabling automation, and continues to do so. And it has been transformative in every walk of life since basically Shockley invented the transistor. But to actually get to answering your question, Jennifer, what about 10 years ago when CSIC was first getting going? What was digitalization like then? Well, we're seeing and we're experiencing the emergence of technologies. So the whole foray to Birmingham in the 18th century is just to emphasize that technologies are always going to be emerging, and they are always going to, in some cases, be completely transformative and completely disruptive. And you know, we are now seeing a convergence of all forms of digital communication enabled by advances in network communication technology, battery technology, miniaturization technology, enabling us to do things faster, at larger scale, and in smaller ways. And the societal expectations to be online, for example, and to communicate 24/7 really is driving this sort of thing. If I think of sensing technologies, they were certainly on the ascendancy 10 years ago. And you know, if I look more broadly, think of the sequencing of the genome 20 years ago. It saw the growth of hugely innovative sensing and ingenious measurement technologies. And coupling that with new emerging computing architectures, cloud computing, for example, it's really democratized, it's really accelerated the democratization of our ability to compute at all levels. And in engineering in particular, there's been a continuation on the use of sensing, measurement, and control. And as more sensing and as more measurements are made, more data is produced. And this is where I think 10 years ago, one of the other buzz phrases that came out was big data. And I think when Robert and Kenichi really started CSIC and started thinking about measuring and sensing, we were certainly within the big data boom. And this was because of the convergence of digitalization at the much broader level and this production of data and producing data at levels that, you know, we could just never have thought of a decade before that. And so, you know, sensing, measurement, big data, very much the outcomes of digitalization then. And CSIC pioneered the exploitation of sensing and measurement in the built environment at that time. It adopted these technologies. It demonstrated the technology's worth, and persuaded the base, persuaded the sector of the need and the benefit to adopt to that. And so what of now, as we stand at the precipice of the next 10 years? Well, what are the new buzzwords? Well, we've got buzz phrases like artificial intelligence and digital twins, for example. And we can see how the availability of big data and advanced computing architectures, democratizing computing architectures such as cloud, and the rise of AI technologies, what we see is that digital twins is exactly the same. Computational engineering has had a massive impact. You know, it emerged from the development of computer-aided design, computer-aided manufacture, and the influence of things like finite element methods to actually simulate the systems that CAD systems were able to digitally create, digitally store, digitally, test and evaluate. We now really can see that, as I said, computational engineering and big data are now allowing us to start to think about coupling the physical reality with its digital representation. As you said, Jennifer, we now have these systems of systems. We now have not only just the physical asset, but the digital asset as well, which carries value. And the cyber-physical relation is one that is now going to be really quite transformative in terms of commercial enterprise and also in terms of engineering exploitation. And, I think this is one of the things that CSIC does, certainly as a newcomer, it does best. It couples sensing with data, with modeling, with prediction. And of course, the sensing itself is being transformed. I mean, if you think of technologies such as drones are being used, or certainly exploratively being considered by the post office. Hospitals are using them. Amazon's certainly looking at them. In fact, 2 weeks ago, I spoke to a startup that are developing drone technology to more safely transport objects on building sites. And the ability of fleets of drones to capture data for energy use, heat distribution, transportation at the individual level, at the urban, the city, the regional, the national, the transnational levels, brings the possibility of scaling what CSIC has been pioneering in terms of sensing to far greater and far newer levels. And then we can go beyond the sky to satellites. And given the global sensing system, one might ask, where is this all going to lead? So what are the next 10 years? Well, I'm going to quote Alan Kay, the computer scientist who's best known for pioneering object-oriented programming and the windowing graphical user interface. And what he said was that the only way you can predict the future is to build it yourself. And I think this is exactly what CSIC has been doing for the last decade and was going to be doing for the next decade. And I mean, Jennifer, you've really been on this journey as far as the built environment is concerned. I've kind of been all over the place in various sectors and seeing it, and only just starting to become familiar with the, let's call them opportunities for digitalization in the built environment. What's that journey been like in this particular space?
It's been a really interesting journey, I have to say. I mean, I joined CSIC 8 years ago now, and the whole journey was in its infancy, really. The industry was using traditional sensing methods, but a lot of those are very manual and are periodic, so they rely on a person to go and take a measurement. So this idea that you could deploy sensors and get continuous data was very much a sort of new idea in our industry, and people were wondering, well, what could we use it for? How might we use it? So when I first arrived at CSIC, there was quite a lot of interest from industry, but not much uptake. And what uptake there was a little bit more like sort of playing in the sandpit. We have these sensors around us. Let's see what they can do. Let's throw sensors at a bridge. And there were a number of bridges that sort of 10 or even more years ago around the world had huge amounts of sensing put on them. But the challenge then was people, because they were sort of exploring the toys, if you like, trying to work out what they could do, they didn't have a purpose for the data. So these sensors quite often were then only looked at for a few weeks or months, and then they lay dormant. So there was, as I said, there was enthusiasm, there was a willingness to explore how sensors might help, but there was a caution as well, because people perceived them as being high cost and people weren't really sure what the benefits were. But alongside that, there was the development of the whole sort of BIM, building information modeling concepts, which, you mentioned finite element analysis building on CAD. Well, BIM built on CAD as well. People realize that we can do these renderings in 3D. Well, why don't we all work on a common model when we're doing design, so that we don't bring the designs together and then find they don't work? And then they recognized that you could then use those models for a bit of prediction. So you could do a walkthrough of a construction process and work out, where things might not work because you've put something up and then you realize you've got to push a crane through or something like that. I mean, I'm sure that there were much more challenging problems than that, but just to give an example of the sort of thing you could start to explore. What order should you do construction in? So these two activities were really happening in parallel. There was sensing, there was monitoring, and there were three activities: sensing, monitoring, and then the development of BIM and the ability to visualize data in 3 dimensions. And that, thanks to the government's BIM mandate, really sort of rolling out across the industry. And over the last 8 years, what I've seen is much more of a coming together of these three ideas now. So people are recognizing the value of the sort of the BIM architecture, if you like, for through life management of assets. People are recognizing that while periodic monitoring may be fine for some things, actually for other things, having continuous, or the ability to have continuous data and to capture the behavior of an asset, or the behavior indeed of an entire system of assets, without interruption, both in the physical, in the time dimension and in the physical dimension, is really helpful. So, ubiquitous sensing, physically continuous sensing gives you a much different picture to a small number of individual sensors dotted around a structure or a system. So we're starting to realize that we can do so much more with more data. I think the challenge the industry still has is that to some extent, people are still playing in the sandpit a little bit. So rather than standing back and saying, what should I measure and what data should I collect? People in our industry are still really thinking about, what can I measure? What can I collect? And those two things are very different. Just because I can collect data doesn't mean it's useful to do so. And if you have so much data that you're not quite sure what it's for, then you end up in a position where you get overwhelmed, and often people give up because they say, well, I've got all this data, it's costing me a huge amount of money and I don't know what to do with it. Whereas if we start from the other end of the telescope, and this is something that I think CSIC has been arguing all along, but it takes a while to bring everyone on the journey and to demonstrate how to do these things, is to stand back and think about, well, actually, what is it I need to know for my construction process, or to inform my design process for the next project, or for my asset management and monitoring and operation? What data do I need and when do I need it, and in what kinds of format and how frequently? So that you can then start to design your data architecture and your data capture system to give you the data you need and to help create the sort of the information base that you need. Because I think one of the challenges for us in our industry, as you said, big data is certainly not unique to civils. And if anything, there are many other industries who have much bigger data than us. The astronomy researchers, for example, they're always going to be in the, I don't know what number they've got up to now, but they're capturing vast quantities of data very quickly. So they're having to grapple with the size of data. The challenge we have is that we have this huge variety in our data. So we have assets that live for 200 years or more. How do we manage data through that long time scale of the life cycle? We have information needs that range from many times a second for things that are safety critical for operation of a road or a water or a power network, versus things that we only need periodically because they're much more about the sort of the long-term behavior of an asset. And how do we marry those two, the variety and the timescales that we need to capture? And then we've got a huge variety in the types of data that we want to capture, because our systems are not only engineering systems, but they are systems that are providing services, quite complex services to people. So user data matters. And so how do you bring together user data and socio-demographic data with engineering data. So there's all of this sort of real potential and really exciting opportunities to do much better and greater things with data in our sector, but it's quite a complex picture. And we are an immature industry when it comes to handling data. So that can feel a little overwhelming. But I think what's great is there's an increasing appetite for this. There's a real appetite now for exploring data and extracting value from data and for seeing data as an asset. And we're starting to see infrastructure organisations appointing data asset managers and cities appointing chief digital officers and chief information officers to really recognise and capture that value. We've seen Highways England employ a consultancy to value their data, and they found that it was worth a third as much as their physical assets. So, you know, that's a huge amount of money. When you think how much the value of the physical assets Highways England holds, the value of its data asset is a full third of that again. So I think there is much more of an appetite and a recognition that we sort of need to create this discipline in a way, in the same way that we have the sort of the physical understanding, we need that digital competence and digital understanding in our industry, and they need to develop the skills as well as the tool sets. So looking ahead, what I've seen is the sort of the sensors monitoring and BIM come together into the early stages of digital twins and the early stages of valuing data for the myriad of things it can help us to do. And I think the interesting challenge going forward is how do we harness that in a way that is as useful and usable as it can be? Because when we come back to what I said at the very beginning of the talk, you know, our built environment is this complex system of systems. It's interreliant, and therefore the data systems are likely to be interreliant in some way. They're going to need to share data, but we have to be aware of the cybersecurity issues and how do we manage the sharing of data and not just put up firewalls, but perhaps fire breaks between systems. So there's a lot of technical stuff that's actually not just about the data and how we manage data, but also how we manage security, how we understand the data asset in its context of a city or an organizational operation, as well as the sort of the information that it's yielding. So I think there's a lot of exciting opportunities out there, but I hesitate to predict where it's going to go. And I'd perhaps like to flip back to you, Mark, for a few closing thoughts, because you've been operating in this exciting digital world and you've seen a number of other industries kind of capture the opportunity and then sort of, if you like, surf that wave. Where do you see the wave surfing to in the future, both for our industry and for others?
I mean, one thing that is now starting to dawn on the tech sector, so the Amazons, the Googles, the Facebooks, and so on, is that the whole, I'll call it infrastructure sector, as they would describe it, is now in similar fashion to when Google started. You know, data was being generated by the kind of nascent World Wide Web, and you know the way it was growing and the way that you know, data was becoming available, and the tools that were going to be required, and the drive and the pull, and the commercial imperative to develop these tools. They are now seeing the exact same, you know, in smart cities, in digital twins, and so on. And so I would imagine that we'll probably see some serious disruption when, you know, I could just imagine Jeff Bezos waking up one morning and deciding, right, that's it. We're gonna do an Amazon of New York City. You know, we'll just take all of the smart buildings, you know, the smart freeways and so on, and we will, you know, make that data available, and we'll start to build you know, an environment where commercial activity, where entrepreneurs can come and start to, you know, come up with ideas and potential commercial schemes for services and so on. And it wouldn't surprise me if something like that happened. And it happened because of probably one of the major pools that we're experiencing at the moment. And it's one of the biggest and gravest societal challenges we face, which of course is climate change. And the built environment, cities, regions, and their interaction with the natural environment is going to be one of the main theatres of this battle. So I think that we'll see a dramatic increase in the urgency to innovate and to deploy in a digitalization context. I think a lot of that will be driven by necessity, rather than by commercial imperative. And again, if we just look at what CSIC has now put forward for its mission statement for the next 10 years, and CSIC is positioning itself to provide leadership and to deliver, in this respect. So, so I think that's where I see it, that there will be a potential convergence of the tech sectors with the construction or the built environment sector, and I think we'll see some very exciting and probably quite disturbing innovations in some respects. But I think, again, going back to 18th century Birmingham, I think that's what we're going to see. We're going to see this confluence of innovations, innovators, which are all based on digitalization, and I think the built environment sector stands to really gain, and has to, because of the real challenge that we face as far as climate change is concerned, and the way that business is undertaken. Now that's the same everywhere. I mean, AI, the amount of energy that AI tools are producing for the likes of Google and Amazon is criminal, and they are now really starting to have to think very, very carefully and disruptively about how they're going to change their mode of business. So yeah, that's how I see it at the moment. But the thing is what we see now will change tomorrow and change the day after, and so on. And we just need to be agile and nimble enough to appreciate that and to go with it.
Yeah, I fully agree with that, Mark. And I think your point about climate change is very well made, that actually we really need to exploit the value of data as an engineering tool to help us manage both our impact on the climate and the climate's impact on us. And in terms of managing emissions, as you say, we've both got to use data, but we've also got to be conscious of its own environmental footprint, and work with the tech sector to both help the built environment professionals do our job better, but have the built environment professionals work with the tech sector to help them manage their energy requirements and so forth. So I think that's a nice place to bring it all together, and perhaps to end the fireside conversation. I know